So today our main topic is kind of really called the problem I faced, and this is also about the B3 but implementation. Um, Actually, it's been a month that I'm trying to implement B3, and it's kind of hard. Well, so what it means kind of hard is that the leaf node deletion is kind of easy, but when it comes to the like when it comes to some kind of, how do I say it, when it comes to like some kind of internal deletion, it's getting really hard. So let me try to explain this for you more. Yeah, let's like switch this part like this. Let me just try to like make it as visible as possible. Why does it look like this? Okay, so like this part is going to be here. I think 28, 28. Huh? We are on 28. Should we go? Yeah, it should go last part. So this is really the like dummy data of the B3. So this is the root, and this is the left part, this is the middle part, and this is the right part. Okay, but leaf node deletion is really easy. Example, if you wanna try to delete, which is train. Let's say your minimum degree is 3, so your max key is gonna be 5, and minimum key is gonna be 2. When it goes like deleting the leaf node, it's kind of easy. Let's say your target node is 29, so you're trying to delete 29. What you have to do is this deletion calls underflows. Since your minimum key is 2, when you're trying to delete 29, it's because you only have one key, so you can cause underflows. To solve this issue, you borrow from siblings. Sibling is also this part, and sibling is also this part. So there are siblings here, yes, and based on this your target node, you have to borrow from the siblings. See, if you're trying to borrow from siblings, if it's example you borrow from 26, but this also calls underflow. Right? If you're trying to delete 26 and put here, there's going to be underflows. What you have to do, you have to also compare, is this cause underflow? If you're trying to borrow, is cause underflows. So if you're trying to borrow from the right part of the 29, this one causes underflows. So you have to borrow from the, if you're trying to borrow from the right sibling, you have to get the most left part of it, which is 31. But actually, if you're trying to put this 31 into just this part, it will cause more issue because like 31 is, if 31 is here and replace 29, that will cause some kind of issue because 31 is actually bigger than the 30. So 30 has to be on the right, not the left. So the best idea is go to the parent, put onto the parent, and then let 30 replace the 29. So it's going to be like this. 39, put 31 onto this part. Yes, we're good. Let's say your target key is also 30. If you're trying to delete 30, you have to borrow from the siblings, but even the right siblings are isn't that doesn't cause underflow. You borrow the same stuff. You borrow from the right, and you push in the parent. But whatever, so that's how it says. But let's don't trying to delete 32. Ah, wait, sorry. Why is it like so you gotta, if you're going to delete 30, you have to replace as like this. But the issue is when trying to delete, which is this bar, you leave node, but when you're trying to delete some kind of 4, if you're trying to delete let's say 2, if you're trying to delete 2, then you have to borrow from siblings, right? But that costs even under for you can borrow from the siblings. What you have to do is you need to borrow from the parent. So you pull the parent, you push into current, and you merge with the siblings, which is 4 or 5. So which is gonna be 4 or 5 like this. And you now delete 3. But also this causes a problem that this node is already kind of how to say it, it's already under cause underflow. So all you have to do you do same stuff, which is pulling the 9 and merge with the 15, 6, 9. So this is gonna go here, and this is gonna go here, like this part. But what I'm trying to say is, the extra is easy. But what if I tell you, when you try to delete, when you're trying to delete 3, if you're trying to delete 3, that would cause underflow, right? If you're trying to delete 3, that would cause underflows. And what does our like the papers or whatever the PDF or PowerPoint from the college talk about this is, if you're trying to delete internet node, whatever you borrow from the siblings, if you're trying to borrow from siblings, as you gotta like this. You gotta borrow 2 and 2 again. But if you're trying to if you're trying to borrow 2, your pointer should be go to the 1. So that means that if your pointer is 1, you do the same stuff of the some kind of like merging and splitting. But this is really how I face those kind of logic are already hard. I tried to implement it with a TypeScript on it. The first thing was to think about recursion, and next thing was targeting the pointer. Since this is recursion, you have to really track the pointer based on the argument, and this was really hard. But so that one is making me really tired. But I think I'm just gonna trying to make it. It's already done. So it's already just internet node on deletion part. It's already causes the problem. So I think after that, after making some kind of index arguments of the B tree, I'm just gonna try to implement more with the B plus tree. With the B plus tree, and after that, I have to make it as a buffer, because normally we store on the index file as a buffer. So I'm just gonna try to make as a buffer index. So I think this is the happiness. Bye bye.